Good afternoon, ladies and gentlemen. These are interesting times, and I really enjoy to be part of this transformation that we see all over. And today I would like to focus on which role we think 5G will play in the move towards the industry digitalization. To illustrate the pace that we are currently perceiving, we've picked up this slide here. It took 100 years to connect 1 billion places via fixed telephony. It took only 25 years to connect 5 billion mobile users with mobile telephony. And now we've started to connecting devices. Until 2020, we predict that in total 26 billion devices will be connected. And this will primarily happen because we are entering a new domain, we are entering new use cases. And now I would like to have together with you a look at those use cases. Of course, we continue to look at the use cases that we're used to when we think about mobile communication. Mobile broadband, access to videos everywhere you like. We need to enhance the capacity of our systems. But what is now new is that we also look at industrial use cases. For example, we are looking into the control of heavy machinery in mines. This is a very interesting example that we are currently studying. Another example, and that's more the topic of this session today, is the area of the wireless industry production. How to use wireless communication in production environments. A third very important area for us is the automotive industry. We would like to be part of enhancing the road safety, the efficiency of the traffic on the roads, to support logistic applications, and so on. And last but not least, there is an area that we call massive machine type communication. This area is about small devices that collect a lot of data to provide more insights in order to enhance processes. If you're interested in these use cases, I would like to invite you to come down to our booth to discuss these use cases in more detail with us. In particular, we're showing this connected vineyard that is depicted here on the slide. Yeah, looking at all these use cases, we've started to derive the requirements. So what is really needed from a 5G network in order to be able to support those use cases? And here I would like to start on the right. This massive machine type communication, here it is really important to make sure that devices can work based on their battery for a very long lifetime. We are thinking of a battery lifetime in the order of 10 years. That is really a challenge, but we are looking into this and are working with solutions. Higher peak data rates and higher system capacity, that is obvious. The amount of data that we are transmitting in our systems is increasing at a dramatic speed, and of course we need to address that. More interesting is probably that with reducing the latency in our systems, we can actually address use cases that we were not able to address before. We are thinking of reducing the air interface delay down to 1 millisecond. But beyond these more technology-driven requirements, we see also other requirements. For example, we need to make sure that our systems are flexible to support this wide variety of use cases that I've just talked about. At the same time, since the radio spectrum is really scarce, we need to look into spectrum-efficient means in order to achieve what we would like to achieve. Security is one of the most important topics. It's about user privacy, protection of business-critical communication, and so on. And last but not least, we need to design technology that is affordable. Only when our technology is finally used, it makes sense to invest in this type of technology. So how will the radio access in 2020 look like? This is the vision that we have. LTE is a very strong technology, and we are continuing to build on that technology. Therefore, we are investing into the LTE evolution. And at the same time, we think that in some areas, the evolution of LTE is not enough. There we have to look into new air interface technologies, and that we denote here as NX. In particular, we are addressing higher frequencies, higher spectrum bands with this new technology, because only there we have spectrum bands available that support very high data rates. So that is a new technology dimension for us. That doesn't work. Okay, but 5G is much more than the radio access itself. We need to take a holistic view at our networks. It's not enough to enhance the radio access network. We need to look at network management solutions. We need to look at solutions how to orchestrate the functionality that we have in our networks. They need to be well aligned with the applications that run on top of our networks. And last but not least, the cloudification, the cloud infrastructure, to integrate that into our overall network is key. And at the same time, having a powerful IP infrastructure that is able to transport all the data that is generated. And here it is then important, I've talked about the flexibility before. Here it is important to understand that it is economically not feasible to derive specific solutions for all different industry areas. So we would like to build a 5G platform that is able to address all the different use cases, and then to use modern technology. We've heard the keyword SDN and network function virtualization today before, to use these technologies in order to create a flexible network that can be configured in a way to support the various different use cases. For example, if low latency is required, it should be possible to configure the network with SDN mechanisms that the main functionality is running locally. You have to think about that a distance of 200 kilometers corresponds to 1 millisecond delay in a optical fiber transmission, and that means if you really want to have low latency, it's not possible to run services in a remote cloud because simply the distance is too long in order to achieve low latencies. So one common network platform that allows to address these different use cases, that is what we need, and our keyword here is network slicing. So we would like to address these different use cases based on the same hardware platform by simply reconfiguring it for all the specific use cases to address the requirements that are needed for those applications. Yeah, then 5G is a really hot topic at the moment, and I think one reason is here that everyone feels the impact of this new technology. We also perceive that only collaboration across industries allows us to develop the solutions that are viable and that address the use cases and requirements that we see. And therefore, we've launched a program, 5G for Germany, where we work together with research and innovation partners in order to develop the solutions that make sense. There are more examples of such innovation platforms. The most prominent one driven from the academia is the 5G Lab Germany that is hosted at the TU Dresden. The Deutsche Telekom, for example, is running their innovation lab activity 5G House. That's also another prominent example. And on top of that, we also work in collaborative projects together with partners from research and industry. And here I would like to give now one example of one project where we do this, and that is actually the COI project. In the COI project, we look at coordinated industry communication. So we are considering a factory hall scenario, and there we work with academic partners, small, medium enterprises, but also the big players in that industry. The project is supported by the German Ministry for Research and Science. And more in detail, we look at this scenario here, a normal factory hall where several different automation cells are operated in this production environment. And we look at the scenario if we are going to replace the cables in that environment by wireless communication. And if we do that, we first need to optimize the link that handles that kind of communication. The requirement is that low latency should be achieved and a very high reliability is provided in order to have a reliable production facility. For that, a new air interface is needed, and in this project we are working towards that new air interface, the characteristics for it, and that we will feed into the 5G standardization track. The second topic that we are dealing with in that project is about the interference that we typically perceive in such environments. If there are many devices communicating in such an environment, it is difficult to achieve the reliability because the signals are disturbing each other. And therefore, we are looking into using LTE as a technology to control the interference, to assign resources in this production environment in order to have a much more reliable communication. And now I'm actually coming already to the end of my presentation. I would like to summarize what the key points for 5G are. Looking also at the discussions today, I've seen this in many other presentations. This is a collaborative industry journey that we are currently in. 5G is only an enabler for Industry 4.0. And that is why we need to work together in order to make the solutions fit. I think that 5G provides a very powerful platform because we will really enhance the capabilities of this system. But how it is exactly used in different environments for the automotive industry, for Industry 4.0, in the logistics area, this is something where we need to collaborate in order to come to good solutions. I've stressed the point that we need one network that is able to support all the different use cases. And that we study and support with these new technologies, software-defined networking and network function virtualization. And last but not least, we see it as our mandate to drive the technology evolution forward of the radio technology itself by studying antenna solutions, by looking into solutions to achieve low latencies or have an optimal battery efficiency. Thank you very much for your attention.